You're good.
All right, so hello everyone. My name is Chris Pemberthy. I am the enrollment coordinator for Parks College at St. Louis University.
My name is Mark Notham. I'm an admission counselor here at St. Louis University as well.
Okay, excellent. And my name is Ronaldo Luna. Here are our names on the screen. I am a professor and department chair of civil engineering. So today we're going to give you a brief presentation, 15 to 20 minutes, overview of the civil engineering program and the exciting things that our students are doing. So I'm going to proceed with our slides here, and Mark and Chris are going to be here with me to field any questions or just be available for consultation. So let's move to the first slide. Yeah, so the civil engineering program at St. Louis University started about 5 years ago. We actually graduated our first class in 2013, and it progressively grew to about a size of 15 to 20 graduates every year, and we became ABET accredited immediately after graduating the first class. So we enjoy that accreditation, which allows you to go into to further your career and take additional examinations to get board certified as a civil engineer. So we enjoy small classroom environments and very hands-on laboratories, internship experiences, and study abroad and research with faculty. And all faculty have PhDs. We have 3 full professors and 3 assistant professors, and a plethora of adjunct professors that support us with the professional aspects of the degree. But today I want to focus a little bit on what is civil engineering and what distinguishes our program from other civil engineering programs, being Jesuit University, the identity that we behold, and importance that we have in student interaction and faculty. So as you can see here in the second bullet, I have a technical specialty area. Civil engineering has many sub-disciplines, probably about 10. At St. Louis University, we focus on 5 of those: environmental engineering, geotechnical engineering, structural engineering, transportation engineering, and water resources. So I have a series of slides that have some images so you can start becoming familiar with what these disciplines are. Each one of these disciplines, you can take it all the way to a PhD in major universities. We do have a PhD program, and our faculty have graduated 3 PhDs to date. In fact, yesterday, 2 of them passed the dissertation exam. So here, my next slide shows some icons of structural engineering. To the right, we have the Duberg Tower in the United Arab Emirates, the highest vertical construction in the world. To the left, we have a bridge, a pedestrian bridge, showing some exemplary artistic inclinations of a very unusual cable-stayed bridge. And the classic icon in the background in the bottom right, you have the Golden Gate Bridge built in 1937, which connected Marin County and the peninsula of San Francisco in the Bay Area. All these is what really makes civil engineering noted and famous, because those are the structures that people actually get to see and use every day. There's a lot more to civil engineering that is not on the surface, and we will touch in some more detail in some of those aspects. For example, transportation engineering. We all experience and live in a world that requires mobility. To the left, we have extreme congestion, and that is due to poor design and planning, and probably the lack of use of multimodal capabilities. If we do not have the foresight, or we are not able to calculate how the system is going to be loaded, and that starts from census data in planning how people are going to generate trips every day, we're not going to be able to manage the flow of traffic and provide enough alternatives. To the right, what that icon shows, it shows the geometry of a road. You would think that it's a simple issue to have a road just going to follow the lay of the land. In fact, if you want a highway, you need to have a comfortable transportation from one place to the other. You really need to design the geometry accordingly to prevent accidents and to have a smooth arrival to your destination. So this is a soft side of civil engineering called transportation engineering. Another aspect is water resources, how to manage the waters that we use for drinking water, to generate power, to actually just control the water during flood events. It impacts all of us. Floods are terrible. What we see here on the left is a breached dam that has failed, and that is obviously when most people notice that water is being retained behind the dam. We take it for granted that the water is being captured for purposes of energy or water usage, but is not something that is being alerted all the time that is something important, but we rely on the systems. And obviously we have pipelines in the right. This is a temperature control pipeline. Geotechnical engineer, that is all that has to do with below the ground surface. So any tunneling, support the structures. To the left, we see the Tower of Pisa, which has a compromised foundation. It has leaned. It became an icon in the town of Pisa in Rome, but it was essentially an engineering blunder, not knowing what were the foundation soils that were going to support that beautiful vertical brittle structure. Now it has been stabilized, and it's an icon for tourists to visit. To the right, we see a drill rig that exemplifies the need to actually have to explore the earth before we build upon it. So that is geotechnical engineering. Environmental engineering is an area that has grown a lot. We have new faculty in this area, St. Louis University. We have the responsibility to build our civilization in balance with the environment, with the human component, and with the built environment. So we need to have these three balances. If we are able to balance the built, the human, and the natural environment, we can have a sustainable civilization to endure. So we have to control and clean our environments and make sure that we do not pollute the environment. Usually the cleanup ends up being a responsibility of our environmental engineering. A big aspect of environmental engineering are the two substances that penetrate our bodies. That can be air. We breathe air, so it's got strong aspects to health, and water, which also penetrates our body, and those are two responsibilities that civil engineers need to design for according to the Clean Water Act and the Clean Air Act enacted in this country in the last 50 years. So that is environmental engineering, a very popular and growing area for the past 20 years. So those were the areas in a fast nutshell that we actually have dedicated faculty contribute their gifts and talents and work together with the students. This slide shows the 4-year Bachelor of Science Civil Engineering curriculum. When you enter, you come in as a freshman, you would come in with most likely a calculus or a pre-calculus course. You're going to enter into Calculus 1 and Calculus 2 in the freshman year. You'll have a few English classes, theology, science, and an Introduction to Civil Engineering course. So that is a very foundational year. Most colleges have similar courses, but we add a few that keep you in touch with the discipline. Then you go, typically a freshman goes home for the summer, trying to transition from to an independent life. You still go back, but you can take an internship. We have a few freshmen that do stay to take an internship if they are ready. And then come back the second year as a sophomore. You will take definitely college grade math courses, science, engineering science, such as statistics, fluids, and dynamics, mechanics of materials, geographic information systems, and surveying. These last two are specialties in civil engineering. And I'm going to talk more about studying abroad that we try to focus in the second semester of the sophomore year, which is in the spring. Junior year, this is the core civil engineering foundations that will prepare you to become a civil engineering designer. And you see the disciplines there listed that I spoke before. This is very heavy on laboratories. Absolutely every single class has a hands-on laboratory with a 2-hour contact weekly with a professor with a PhD. That distinguishes us from other large universities where laboratories are maybe taught by graduate students or the like. So the senior year, after having a very strict and structured junior year, you come into a very options-oriented senior year, where you will take a design capstone course that runs the 2 semesters. You will have electives in civil engineering. You'll have electives for professional preparation, if you're preparing yourself to go to grad school or if you're preparing yourself to go into industry. If there's a particular industry that you're interested in, for example, you want to go into construction, you may want to take some management courses. If you want to go into grad school, maybe you want to take some higher-end mathematics courses or some in the areas that already interest you. So very flexible, and this is where you start really owning your degree, and you're starting to place it into practice in your senior year. So I'll talk here about a few other options, what I call on this slide more about civil engineering. And I think these are the 6 items that actually distinguish us from other programs because we are able to work very closely with the students. We have an American Society of Civil Engineers student chapter. We have an Engineers Without Borders student chapter. We have study abroad experiences in an actual SLU campus in Madrid, and some travel courses as well, internship program, senior design projects, and career placement. So these are essentially the items that are going to be covered in the next upcoming slides. So let's see what we have next. The American Society of Civil Engineers student chapter, we actually just came back last week, actually this past weekend, from the University of Arkansas, where we competed against 20 other schools in the Mid-Continent area. And we see there in the upper left, we see the steel bridge competition right in front of the poster, and the bridge that the students built, 100% built from scratch by the students, having to span about 20 feet and hold prescribed loads. And they have to build the bridge in a clocked manner, and they have to actually span over an artificial bridge. They cannot step onto that area, and it becomes a dynamic challenge for the students to build that, and you compete against other schools. It's quite fun, and this is usually in an auditorium or a gym of the university. And this chapter of the American Society of Civil Engineers is in the city of St. Louis, and we enjoy a lot of contact with professionals. So we also host the Order of the Engineer, which is an oath that we make at the senior year. We invite professionals to come and make the oath to uphold certain ethics of how we're going to conduct ourselves in practice. Actually, one of the ceremonies, this ceremony is called the ring ceremony, and you get to wear a ring, a stainless steel ring in your pinky hand, like I'm wearing here, that serves as a constant reminder. The ring goes in the pinky hand so that every time that you sign a document, you are reminded of the ethics that you're supposed to uphold. So very similar to other professions in that you make an oath to be the best you can be. In the bottom right, we see a photograph of the students in a field trip. Usually we have contacts with professionals that allow us access to construction sites. And when there's good weather, we step outside quite easily. This slide is also a competition. This happens to be in the state of Missouri. They built the canoe, where you can see draped in the inside of the concrete canoe is the flag of the city of St. Louis. This canoe was built 100% made out of concrete, and yes, we are able to make it float using the principles of Archimedes, and displacing your weight in the same volume of water. We can see here, this is the ladies competing with the women's hit, and there's also the male and the co-ed competitions. This happens in a large body of water, and it's kind of fun. Happens in the spring, and we just came back from Arkansas, like I said, and students had a lot of fun. So that was the American Society of Civil Engineers, very tied into the discipline. More generalized, when we start working with other students, we have Engineers Without Borders, where we actually welcome any type of engineer to work in this chapter. I happen to be the faculty advisor. We have electrical engineers, mechanical engineers, biomedical engineers, However, most of the projects needed in third world countries are water projects, and that is usually the responsibility of civil engineers. So we have a strong component in designing the systems. We see some images here. The students are doing some water chemistry here in the field. There's some community meetings, looking at the results of the water tests, and some of the community. This is primarily a farming community, and those are potatoes shown on the floor. This is in Bolivia, 14,000 feet above sea level in the Andes. However, that project in Bolivia, we worked in conjunction with a professional chapter. The Engineers Without Borders SLU chapter has identified a new project, moving on to be a little bit more independent. This happens to be in Kenya. We're gonna take part in an assessment trip. It's again a water sustainability system for about 40 kids. There's a very moving story about this Esther House. This is an orphanage in Kenya, linked to a community here in Webster Groves in Webster, Missouri. So we have some families that are teaming up with our student engineers to bring water to this orphanage in Kapenguria, Kenya. So that is Engineers Without Borders, again, extracurricular activities. A little bit of a study abroad. I have developed a new course, Spain Ancient versus Modern. I'm just going to show you some photographs here. Essentially, the course is a 2-week course, and it takes you into old Spain and all the civil engineering infrastructure and architectural as well. We see the Catedral of Segovia, the Monasterio of Guadalupe, in some water infrastructure that are still operational in the feudal age, the Canal of Castilla, La Casa de la Moneda, which actually generated some of their mills using water power. And we see some of the exclusas in the bottom left, which actually controls the level of water in canals for navigation. All of these are extremely old and still in operation in Spain. We have the very famous Aqueducto de Segovia. This is a double arch, extremely high. You can see the scale of one person there. Aqueduct that move water from one side of Segovia to the other. And all the reservoirs and dams that were built many years ago. After 1 week of travel, we come back to Madrid. We have another morning of lectures, and then we take a high-speed train to Barcelona and contrast modern Spain and the modern infrastructure. We're going to visit the largest port in the Mediterranean in Barcelona, and the Olympic Village in Barcelona, and the Tibidabo and the Catedral de la Sagrada Familia, extremely famous, still in construction. I don't have an image of that, but so much fits in a slide. Here are some other modern bridges. The Spaniards are very famous for their architecture renditions, and an engineer has to make it work to be able to carry the load of pedestrians or traffic. And here's some more examples of modern infrastructure. This is one of the last structures that we're going to visit. This is an active dam. It's a power dam, and we have gained access to this high security facility. And we're going to go into the galleries, which is the interior of this arch dam in the La Presa de Altazar. And this is close to Madrid. And obviously in Madrid, we get to visit the Real Madrid Stadium and many other amenities that, and after that, students typically travel all of Spain. However, if you want to entertain being more engaged academically abroad, since we have a campus in Madrid, I am showing in this slide the first 2 years, the freshman and the sophomore year. And as I mentioned before, in the spring semester of the sophomore year, we are making sure, or we make sure that all these courses are offered in our Madrid campus in close coordination with Dr. Gasmi, that guarantees these offerings in mathematics, engineering science, and this essentially gets you ready. You would come back the summer after, because the spring goes from January to May. Summer you can stay abroad, visit abroad, and then come back in the fall to initiate your junior year. So it's after your junior year that you are better prepared to enter into an internship experience. Our faculty focuses on identifying opportunities in the St. Louis metro area with private construction firms, private design firms, water utilities, transportation, state officials, or federal agencies like the United States Corps of Engineers that has a district office in St. Louis. This year, in 2017, we were able to get, without much work, 35 civil engineer internships listed with multiple positions available, and our students are enjoying the proximity of the campus to all these agencies and private industry to ensure you get an internship. We are, given that these opportunities are very attractive to students, we are starting a new program where when you enroll in the program, there's going to be a step-by-step procedure where we're going to guide you and guarantee that you are going to get an internship. If you follow the steps and you keep up your grades and keep a good profile, we guarantee that we'll find you an internship. Why we can promise this guarantee is because we have a small program and we know what are the skills and the strengths and weaknesses of our students, and we feel very comfortable being able to place you in an internship here in the St. Louis metro area. So in the senior year, you enter into a year of much more flexibility, and there is a 2-semester full-year course called the Senior Capstone Design, and you identify a project. First semester, there's lectures, guest lectures, you prepare a proposal. Second semester, you go into full design, and you compete with all of the other Parks College projects. And what we see here, I have cropped a few images of what just got published. These are our 15 students that are graduating this semester. We had 2 teams competing for a green roof option here on campus. And this is an underground structure that has a roof and a number of lectures below the ground. And we had a transportation project in 14th Street, multimodal redesign, and the Oliver Hall retrofit for structural engineering. So in your senior year, very close to graduation, which is this time of the year, April 25th is today's date, we have students presenting poster sessions, and there's some judging that takes place, and you get exposed because we invite industry and other universities and the adjunct professors and the faculty, of course. So then we feel that through this 4-year intense civil engineering experience, we feel very comfortable to get you into graduate school or into the workforce. This slide shows the U.S. News and World Report ranking of the 2017 best engineering jobs. Not surprisingly, environmental engineering is at the top as the number 1. And we have civil engineering ranked as number 4. I strongly suggest that you peruse these websites. There's another one that is quite popular too, which is the Bureau of Labor and Statistics. It's bls.org, where you can go and see what are the employment opportunities and the demand in the next 10 years. Civil engineering ranks quite high in growth, since we need to rebuild our country that was essentially built in the 1950s. And there is strong infrastructure rebuild from current administration, and we're hoping that we're getting bipartisan support to rebuild our country. So with that, essentially kind of wrapping up here, that's an overview of about 20 minutes of our program. Thanks for your attention. Again, my name is Ronaldo Luna, Professor and Chair of Civil Engineering. My email is there, and my friends from admissions.
And if you have any questions regarding the engineering programs with the admissions process, please feel free to reach out to me. Again, my name is Chris Pemberthy. My email is on the slide here.
And my name again is Mark Notham. I'm admission staff here. So if you have questions regarding the admission process or your next steps to attend SLU here in the fall, reach out to my email address located in the bottom of the screen where I can answer those questions for you.
Okay, thank you very much, and have a great day.
Thank you. Do you want to end the session?